one here. Then the same applies to this individual or organism. Also, yeah, there are those ones only. So, how many are they? We shall write phenotypes. We shall write phenotypes. Offspring phenotype. Offspring phenotypes. There are various phenotypes. Offspring phenotypes. So, first of all, we have those offspring which are tall, then red flowered. Tall, red flowered. Tall, red flowered. They have this mark here. I will put it in brackets so that I don't get any disturbance. Tall, red flowered. Then I will count them. 1, 2, 3, 4, 5, 6, 7, 8. They are supposed to be 9. Let me see once again. 1, 2, 3, 4, 5, 6, 7, 8. Thus identify another one here. So what I can see is that here we have small t, capital R, small r. Then here everything is okay. 1, 2, 3, 4. I can come here. T, capital R, small, capital T, then small r. This one here, capital T, small t, capital R, small r. This one here, capital T, then small t, small r. Then here, this one also okay. This one here is can you see? I can see capital T, small t, then capital R. I'm supposed to be here. Capital T, small t, capital R, small r. This one is right. What about this one here? Capital T, small t, then capital R. I drop here. I see. That is small t, capital R. Then this one here, I gonna see small t, capital R, then small r. Here I'm seeing, here I can see capital T, small t, then capital T, small t, capital R, small r. This one here, capital T, small r, small r. This one here, capital T, I mean small t, capital R, small r. Then this one here, I gonna see small t, capital R, I mean small r. So what is happening? 1, 2, 3, 4. Then 5, 6, 7, 8, 9. Right. tall red flowered, they are 9. There are 9 plants. 9. Can say equals 9. Then what other genotype? So I can start here. This genotype is tall white. So I can give it a mark as round. Like that. Round. Tall white. So I can identify tall white, tall white, tall white. So this is tall white. This is also tall white. Due to the same mark, I'm putting a small 0. Then this one here is also tall white. I write that. Then I think they are over. Tall white, tall white, tall white, tall white. So tall white flowered. Tall white flowered plants are 3. Okay, we move on. Everything here has been identified. Everything here has been identified. In this column, there is still 1. This one here. So which mark am I going to give? I can give a 0, but I change. So I can call it a dot. This is dwarf red flowered. So all short red flowered, short red flowered, give it the same mark, giving it a dot. This one also is tall red flowered. I give it a dot. So tall red means short red flowered. Short red flowered plants equals 3. 1, 2, 3. Then lastly, I can give an identifiable mark as a tick. That is short white flowered. Short white flowered equals 1. So now I can deduce that F2 phenotypic ratio, F2 phenotypic ratio is 9 to 3 to 1. So this is what we can see. Now, that F2 phenotypic ratio is what we call dihybrid ratio. That is what we call the dihybrid ratio. The dihybrid ratio. So, as long as a particular inheritance obeys Mendel's second law of inheritance, then in the F2 generation, you are supposed to obtain the 9 to 3 to 3 to 1, what we call the dihybrid ratio. That one is very important. The scholars of biology and even the monohybrid ratio, monohybrid F2 phenotypic ratio being 3 to 1. So now, the monohybrid 3 to 1 phenotypic ratio is modified to 9 to 3 to 3 to 1. So now what do we see? In the phenotypes here, there are 2 phenotypic classes which were not there originally. Originally, we had tall red flowered plants and short white flowered plants. But we can see that at the end of it all, we have now the tall white flowered plants and the short red flowered plants. Now, those new characters, or those plants with new characters in the F2 generation, are what we call the recombinant offspring, also called recombinants. The recombinants are the offspring with the new allele combinations, and therefore they have characteristics different from those of the parents, and so we call them recombinant offsprings. So now, how can we explain the presence of the recombinant offsprings? The reason is simple. The appearance or presence of the recombinant offsprings is due to segregation of the genes during meiosis, and then independent assortment. So their appearance is majorly due to independent assortment that occurs during meiosis. So a question may be set, and then you can be required to account for the presence of the new phenotypes. So the reason is easy. It is due to independent assortment which occurs during meiosis. So members, that is the F2 generation of the dihybrid cross. Let us meet another time. Of course, with genetics work, we shall be moving on.